Hi, welcome to OpenLC Solutions. Today we're going through the 2015 sample paper. Now it's only 2 questions long, so I'm going to do both of them in the one episode. The first question says that a survey is being conducted of voters' opinions on a couple of different issues. What's the overall margin of error of the survey at 95% confidence if it's based on a sample of 1,111 voters? Now, margin of error is 1 divided by square root of n, where n is the number of, say, people in your sample, or the number of the amount of data you get back, essentially. So this is 1 over square root of 1,111, because there's that many voters in the survey, and that turns out to be 0.03, and I'll throw in an extra 0 there just for the extra accuracy. In part B, we're told that a particular political party claims that it has the support of 24% of the electorate. In this survey that people took above 243 stated they support the party. Is this enough evidence to reject the party's claim? So number 1, with any hypothesis testing question, you need to state the null hypothesis H0, and that is essentially that the status quo is true, either the thing that was true a couple of years ago, the last time the survey was done, is still true, or this piece of information that someone's trying to give us, we assume that's true. In this case, we're told the political party has 24% support, so that is our null hypothesis. So the political party has 24% support. And what we're going to do is see if that claim is true based on this survey. So we have to find what's called the population proportion, which is the proportion of people in this survey who support the political party. And that, in this case, is 243 out of 1,111. And that turns out to be 0.2187. Then we have to construct what's called a confidence interval. And to do that, we say there's a lower bound, that is the population proportion, minus the margin of error, 1 over root n. And the upper bound is population proportion plus the margin of error, 1 over root n. So in this case, that is going to be 0.2187 minus the margin of error was 0.030. And it goes up to 0.2187 plus 0.030. So our confidence interval goes between 0.189 up to 0.249, or if you like it in percentage terms, you could also say that's 18.9% up to 24.9%. The whole point of this is that based on this survey, there's 21.87% of people support this political party, but that's kind of close to 24%, so maybe the survey was a little bit out and the party's claim might actually be true. To work out if the political party's claim could possibly be true, what we have to say is, well, look, it's 21.87% support, give or take a little bit, and that is the margin of error that we're giving or taking. So it looks like the political party's support is somewhere between 18.9% and 24.9%. Now, the 24% that the political party gave us is somewhere inside this. It's within 18.9 up to 24.9. What we have to do then is write a conclusion that the 24% that we're given is within the 95% confidence interval. So we conclude that technically we're not allowed to accept the null hypothesis. We can't say with certainty that the party has 24% support. What we can say is we can't exclude that, or the phrase that we use is we fail to reject the null hypothesis. So they might have 24% support. We don't have any evidence to conclude that they don't have 24% support, but we also can't say with any kind of certainty that they do have 24% support. So we use this particular phrase that we fail to reject their statement. The second question in the sample paper tells us about a widget manufacturing company that asserts that 80% of its traders recommend their brand, and there's a survey based on 40 traders. 24 people said that they would recommend it, and we have to work out whether or not the trader's claim could possibly be true. So first of all, we always have to write our null hypothesis. In this case, it's that we believe this company that 80% of traders would recommend this company's widget. The way we do the hypothesis test is we work out two things. First of all, population proportion. That is, what proportion of people based on this survey said they would recommend the widget. It was 24 out of 40, which is 0.60 or 60%. We also have to work out the margin of error, 1 over root n. That's 1 over root 40 because there are 40 people in this survey. And that is 0.158. Next, we construct our confidence interval. So the confidence interval is the proportion minus the margin of error up to the proportion plus the margin of error. So that is 0.60 minus 0.158 up to 0.60 plus 0.158, which takes us to 0.442 up to 0.758, or if you like percentages, that is 44.2% up to 75.8%. This company is saying that 80% of traders would recommend their widget, and yet based on the survey, it looks like anywhere between 44.2 and 75.8% of traders would recommend the widget. So the 80% that they gave us is actually outside this interval. And when that happens, we would say our conclusion is 80% is outside our 95% confidence interval. And based on that, we reject the null hypothesis. The last part of this question says that a large group of students has a particular mean height of 170 centimeters, and they give us a standard deviation as well, which is 14 centimeters. We're told that this is a normally distributed thing, and hopefully you've studied those already and you understand what that means. We have to use the empirical rule to find a height interval that will contain the heights of approximately 95% of students. The empirical rule comes in three parts. The first is that 68% are within one standard deviation. We use this simple sigma to mean standard deviation. 95% are within two standard deviations, and 99.7% are within three standard deviations. And you need to know all of those. The one that seems to be important here is the 95%, so we go with this one. Now what do I actually mean by the within a certain number of standard deviations? It means we're constructing an interval just like we did with the hypothesis testing, but rather than using a proportion and a margin of error, this time we're using the mean and we're using the standard deviation. So our interval goes from the mean, x bar, minus 2 standard deviations, up to the mean plus 2 standard deviations. Because we're talking about 95% in this case, if you were asked about 68%, then you have to do 1 standard deviation either side. If you're talking about 99.7, then it's 3 standard deviations either side. So this is going to be the mean, which is 170, minus 2 standard deviations, so that's 2 times 14, up to 170 plus 2 times 14. and that takes us to 142 up to 198. So that is the height interval. So it says 95% of students are between 142 and 198 centimeters. So thank you very much for watching, and hopefully I will talk to you again in the next episode.